Hello students, welcome to your mathematics class. Today in this video, you will learn how to compare two or more decimal numbers. In your earlier classes, you have already learned about decimal numbers. So decimal number consists of two parts. One is called whole number part, another is decimal part. These parts are separated by a dot called the decimal point. The decimal point is used to separate the ones place from the tens place in decimals. Let us see one example, that 38.973. Here 38 is called the whole number part, 973 is called the decimal part, and the point, this dot is called the decimal point. Now let us consider the decimal number 38.973, which is read as 38.973. Now in this decimal number, here 8 is in the units place and 3 is in the tens place. So it indicates that this number has 3 tens, 8 ones, 9 tens, then 7 hundreds and 3 thousands. Now let us write the place value of each digit of the decimal number 38.973. The table is already shown here. We know that decimal point separates the ones place from the tens place. So here in the ones place, the digit 8 is present. So let us write down the digits first. So in the ones place, we will write below the ones place, we will write the digit 8. Then in the tens place, the digit 3 is present. But in 100 place, no digit is there. So we will leave that place. And after that decimal point, the next number is 9, which is the tens place digit. So we will write here 9, then 7 below the hundreds place. And then 3 we will write below the thousand place. So the value of this digits, place value of this digits will be 3 multiplied by 10, it will be 30. 8 multiplied by 1, it will be 8. Then 9 multiplied by 1 by 10. So it will be 9 by 10. So similarly 7 multiplied by 1 by 100, it will be 7 by 100. And 3 multiplied by 1 by 1000, it will be 3 by 1000. So 9 by 10 is equal to, we can write it as 0.9, and this can be also written as 0.07, and this we can write it as 0.003. So in this way we can show the place value of the digits of the given decimal number. So now let us write the expanded form of the decimal number 38.973. So here 38.973 is equal to, 3 is in the tens place. So we write here 3 multiplied by 10 plus 8 is in the ones place. So 8 multiplied by 1 plus 9 is in the tens place. So it will be 9 multiplied by 1 by 10 plus then 7 in the hundreds place. So 7 multiplied by 1 by 100 plus 3 multiplied by 1 by 1000. So which can be also written as 30 plus 8 plus 0.9 plus, we can write it as 0.07 plus 0.003. So if we add this all numbers, we will get the result as 38.973, which is the decimal number here. Now the number of digits contained in the decimal part of a decimal number gives the number of its decimal places. For example, 57.238 has 3 decimal places because it has 3 digits in the decimal part, 1, 2, 3. Let us take another example, 2, 3, 0.7135. So this has how many, after decimal point, how many digits are there? 1, 2, 3, 4. So this has 4 decimal places, because after the decimal point there are 4 digits. So this number has 4 decimal places. Now let us see what do you mean by like decimals and unlike decimals. Now like decimals, decimals having the same number of decimal places are called like decimals. For example, 5.364, 42.028, 29.207. These are all examples of like decimals because they have the same number of decimal places. Let us see the first example after decimal point 1, 2, 3. There are 3 digits. So it has 3 decimal places. Similarly, the second one also after decimal there are 3 digits. So it has 3 decimal places. So these are the examples which having the same number of decimal places. So this type of decimal numbers are called like decimals. We can write one more example also. Suppose 53.777. So this is also a like decimal because it has also same number of decimal places, that is 3 decimal places. Come to unlike decimals. So decimals having different number of decimal places are called unlike decimals. Let us write some example. 25.23, it has 2 decimal places. Then 25.2733, so it has 4 number of decimal places. So these are the examples which are unlike decimals because their decimal places are different. And note, now there is an important rule that the value of the decimal remains unchanged when any number of zeros are placed to the extreme right of the decimal part of a decimal number. For example, if we write 0.97, now this is equal to 0.970. That means if we place a 0 to the extreme right of the decimal part of the decimal number, then the value remains unchanged. Similarly, we can also place 2 more zeros. Suppose 9700, 0. After this 0 we are placing, if we place 2 more zeros, then also the value remains unchanged. So this is an important rule. Now let us see how to convert unlike decimals to like decimals. For example, 7.5, 3.24 and 1.375. These are unlike decimals because they having different number of decimal places. In the first case, after the decimal point, there is only 1 digit in the decimal part. In the second case, 2 digits. In the third case, 3 digits. So the maximum number of digits after the decimal point is here 3. Now let us consider the first decimal number here, 7.5. Here after the decimal point only 1 digit is there. So we can write it as 7.500. If we place 20 to the right of the decimal part of this decimal number, then this value remains same. The value of the decimal number will remain same, but the number of decimal places is here 3. For the second case, 3.24, if you place 1 more 0 to the extreme right of the decimal part of this number, then it becomes 3 digits. So the number of decimal places is here 3. So in the last case it is already 375, which having the same number of decimal places, that is which having the 3 number of decimal places. So all having the 3 number of decimal places here. So we can say that these 3 decimal numbers are like decimals because they having the same number of decimal places. Now let us see that how to compare the given decimal numbers. Now let us consider the first case, that when the whole number parts of the given decimal numbers are unequal. So in that case, the decimal number with greater whole number part will be greater. For example, which is greater, 25.23 or 24.05? So in these 2 decimal numbers, Here the whole number part of the first decimal number is 25 and the whole number part of the second decimal number is 24. So as we know 25 is greater than 24. So this implies we can say that 25.23 is greater than 24.05. That means this 25.23 is greater than 24.05. Now let us see another example that which is greater, 7 or 0.7. Here 7 is a whole number, so we can write it as 7 as 7.0 and the next number is given, decimal number is given 0.7. So let us compare their whole number part. So here the whole number part is 7. In the first number the whole number part is 7 and the second number the whole number part is 0. So always 7 is greater than 0. So we can say that 7.0 is greater than 0.7, which means that 7 is greater than 0.7. Now let us see another example, that 2.651 or 0.908. So here also the two decimal numbers are given. The whole number part of the first decimal number is here 2 and the whole number part of the second decimal number is 0. So as we know 2 is greater than 0, so which implies that 2.651 is greater than 0.908. So in this way we can compare the given decimal numbers when the whole number parts of the given decimal numbers are unequal. So which decimal number having the greater whole number part, that decimal number will be greater. Now let us consider the second type, that the whole number parts of the given decimal numbers are equal and also the given decimal numbers are like decimals. So in this case we compare the digits of the corresponding places of the decimal parts of the decimal numbers. For example, we will compare the digits at their tens places first of the given decimal numbers. If they are equal, then we compare their digits at their 100 places and so on. So we will compare until we are not getting the unequal digits at their corresponding places. So if we get the unequal digits at their corresponding places, then which decimal part having the greater digit will be the greater decimal number. That means, now let us do another example, that which is greater, 0.8 or 0.3. Here both the decimal numbers having the same whole number part, that is 0. So we compare the digits at their tens place. So the digit at the tens place of the first decimal number is here 8 and the digit at the tens place of the second decimal number is 3. As we know 8 is greater than 3. So this implies we can say that 0.8 is greater than 0.3. Now let us do another question, that which is greater, 0.05 or 0.55. Here both the decimal numbers having the same whole number part. So we compare the digits at their tens place. So here the digit at the tens place of the first decimal number is 0 and in the second decimal number is 5. So if we compare them, then we know 0 is less than 5. So that means we can say that this implies that 0.05 is less than 0.55. So 0.55 is greater than 0.05. Now let us see another question, that which is greater, 3.551 or 3.552. Here also both the decimal numbers having the same whole number part, that is 3. Now also the digits at their tens place, here it is 5 and here also it is 5. Both are same, and if we compare the digits at their hundreds place, that is also here 5 and here is also 5. That means the digits at their tens place and also the digits at their 100 place are same. Now we will compare the digits at their thousands place. In the first decimal number it is 1 and in the second decimal number it is 2. So as we know 1 is less than 2. So that means 3.551 is less than 3.552. So in this way we can easily compare the two decimal numbers. Now let us consider the another type, that when the whole number parts of the given decimal numbers are equal and if the given decimal numbers are unlike decimals. For example, which is greater, 0.7 or 0.007? So here whole number parts of both the given decimal numbers are same, that is 0. In the first case also 0, in the second case also 0. So both are same. So now we compare the digits at the tens place. So the digit at the tens place of the first decimal number is here 7, and in the second case it is 0. So as 7 is greater than 0, so this implies we can say that 0.7 is greater than 0.007. So in this way we can easily compare the decimal numbers. Alternatively, we can compare in another way also. If we convert the decimal numbers into fractions, that is 0.7 is equal to 7 by 10 and 0.007 will be equal to 7 by 1000. Now both having the same numerator, so if we compare their denominators, here 1000 is greater than 10, which implies that which having the greater denominator, that fraction will be smaller as compared to the second one. So here 1000 is greater than 10. So this implies that 7 by 1000 will be less than 7 by 10. So that means which implies that 0.007 is less than 0.7. So in this way also we can easily compare the two decimal numbers by converting them into decimal fraction. Now let us do another question, that which is greater, 0.77 or 0.777. Here the whole number parts of both the decimal numbers are same, that is 0. Now also if we see the number of decimal places of the two given decimal numbers, the first one, that is 0.77, it has 2 decimal places, and in the second one 0.777, it has three number of decimal places. So that means the second one having the more number of decimal places as compared to the first one. Now if we compare the digits at the tens place, that is in the first decimal number it is 7, and in the second one also 7. So both are same. Now if we compare the digits at the hundreds place, we can see that both having the same digits, that is 7, and in the second case also 7. So in both the cases these digits are equal, but in the first case there is no digit is left because it has 2 places of decimal. It has 2 decimal places. So as in the second case it is greater, the number of decimal places is more than the first case. So in this case we simply say that as the number of decimal places of 0.777 is more than 0.77, so we can say that (0.777) is greater than 0.77. Or if we convert the first decimal number to like decimal, if we put one more 0 and if we compare their thousand place, then also we will see that 7 is greater than 0. That means 0.777 is greater than 0.77. In this way also we can compare them. Now let us do another question, that write the decimals in ascending order. Here 4 decimal numbers are given. The first one is 18.07, second one is 33.33, then 8.76, then 8.607. Now in this case, first we will compare the decimal numbers having unequal whole number parts. So here the 2 decimal numbers having unequal whole number parts, that is 18.07 and 33.33. So here 33 is greater than 18. So this implies we can say that 33.33 is greater than 18.07. Now in the second case, both having the same whole number part, that is 8.76 and 8.607. So now we compare their decimal part. So in the tens place, if we compare the digit at their tens place, so here 7 is greater than 6, which implies that 8.76 is greater than 8.607. So now we can arrange them in ascending order. So the smallest decimal number is here 8.607, then 8.76, after that 18.07, and at last 33.33. So in this way we can arrange the given decimal numbers in ascending order. So in this way you try some questions which is given in your book. I hope all of you understood whatever discussed today in this video. So thank you all of you and have a nice day.